Hello everyone, welcome to AWS Agent AI Global Hackathon. As a part of this hackathon, we are trying to address a significant challenge that exists in healthcare data integration. Now this integration, it occurs between different healthcare entities trying to exchange patient data. Let's say for example, between an EMR and a lab system. EMR places an order, it goes to a lab fulfills the order and then it generates the report and it sends back to EMR. Now this transaction, it occurs through an integration engine, which most widely known integration is Mirth Connect. Now to address this gap or to create an interface in Mirth, we need to understand the healthcare systems. How we will understand, basically we'll create the technical specifications, how data could how a healthcare data is understood by a EMR versus how it is understood by a lab system. Now we've utilized AWS services. We've tried to build a AI agentic pipeline on AWS, right? What it tries to do is it tries to take raw HL7. Let's go to a whiteboard and then I'll try and explain this. So what we are doing is, so let's understand from a ground zero perspective. So we have what input, we have processing layer, and then we have output. Now in all of these, it's an AWS solution, AWS services solution, right? And we'll see. I'll just touch base which all AWS services have been used while developing this solution. So what do we have as an input? Again, guys, so let's go back. What we are trying to address is understanding healthcare entities from healthcare data perspective, right? So how we'll understand, basically we'll create technical specifications, right? And then build interfaces between these healthcare entities, right? Now to build the interfaces, this is the final stage. Now if we go at the start, what we have is we have HL7 data, which is in V2 format. I'll just quickly give an example later how it looks like. And then we have config files, right? These config files are nothing but the we can say it's like a PDF type of requirements, PDF or requirements in PDF format, let's say in that way, requirements in PDF format. And then the business analyst, right, they understand this requirement and they formulate this into the technical specifications. So these requirements are given by healthcare entities, right? And then BAs, they transform these requirements into technical specifications, right? Now this is the input, right? This is what, so input is, in our case we can say it could be let's say an EMR, right? It could be from any perspective. This could also be input if we consider it from the lab, because either way it acts as an input, right? So what we are trying to do is, so we have HL7 healthcare data, and then what we'll do in this processing layer is we need to, so output is what, let's see, output is It's the XML JavaScript embedded, JavaScript which is embedded in the XML, which can be readily deployed in Mirth Connect, which is an integration engine. This is the final output, right? Based on if this is developed, right, and in that case the EHR data could seamlessly be sent across to lab and then from lab back to EHR. Right, it generates this, and also it generates the HL7 specification. See, what we are trying to do here is there are although this requirement is given by healthcare entities, right? But then we are trying to automate the rules which are mentioned in these HL7 specifications. We are trying to automate those rules onto this healthcare data, and then based on that, it generates HL7 specifications HL7 specifications, and then these HL7 specifications, right, these are used by the developers to create this XML and XML JavaScript embedded code. Now this was actually the traditional way of doing things, but when we do it using agentic approaches, development is not directly needed per se, although developers could see, like, if the transformations are happening properly or not. But yeah, that's the basic game. So we are trying to automate all of this process. So we are trying to automate BA plus development efforts, right? It would, as we can see, right, it would significantly save a lot of time, right? So now let's dive into this heart of this processing layer, right? How we are trying to do this basically, right? So in this processing layer, what we'll do is first we'll parse this HL7 data, right? Parse this HL7 data. Now this is done using custom parsing techniques, because the API libraries which are available, obviously, so this is done using Python scripting language. So Python does have readily available APIs, libraries, which could parse these HL7v2, but then there are a lot of rules, which are encompassing while passing those HL7. That's why we created our own parser, right? So what it does is, let me do this here. Let me put this all the way below, right? I like whiteboarding, so yeah, processing layer. So what we are doing here is we are parsing HL7v2 using custom parser in Parquet format. We store this in S3, and then we run the analysis. On these HL7v2 data using Athena, right? So I just mention here analysis of HL7v2, right? And then let me show you this. Actually, I think that's better, because this is actually the processing layer, right? So as we see here, as you guys can see, this is built using AWS step functions, and these are all these steps. So yeah, these are driven by Lambda functions, Python based. So what we are trying to do here is we are trying to pass these HL7 messages in Parquet format, then analyzing these HL7 fields using Athena, and then we are trying to evaluate these HL7 fields based on the transformation rules that were created by the BAs, right? So this is what I had mentioned here earlier. So BAs based on the technical requirements which were provided by the healthcare entities, right? Let me show you how it looks like. I would need to go to, let's see. Yeah, this is in JSON format, right? So yeah, this is, let me show you how the HL7 message first of all looks like. Yeah, this is, so for now it's just two messages, just because it's a small POC, and these agents, they cost a little more. But yeah, so this is the HL7 message. As we can see, just a small snippet, right? So it has what message header. This is the patient data. Obviously, this is dummy data. Then this contains the visit label details. This ORC and OVR, these both combined contain the order related information, which includes type of order, when it was carried out, by whom, who ordered this particular order, right? Yeah, and then this is this is one of the ADD messages. This is how it looks like. I won't go more deep into this in interest of time, right? But then and then this is the rule set, right? So there are no rule set on MSH, but let's see. So this is, let's see, this is one of the rule sets, right? So if, because yeah, so if PID 3.5, now 3.5 is yeah, this MR, right? So a patient could be identified using different identifiers. Like there's a medical record number. There's also an SSN by which a patient could be identified, and there are multiple ways. So one of the rules that what it says is, if PID 3.5, which is patient ID, and then this is the fifth component of this PID 3, if it is not empty and if it equals to MR or MRN, then copy that particular iteration. Otherwise, if you don't find this MR or MRN, then copy first non-null PID 3.1. Right, we'll see this in action, how it how input values are transformed using this rule set. Similarly, yeah, like we have different rule sets here. Some gets applied depending upon the data, right? Again, yeah, this character length, because we only want, yeah, 8 character lengths, YYYY so only those characters are copied, and there are, yeah, like, different rule sets for each segment. So these HL7 messages, these are separated using this segment. So this is a single message, and this single message consists of different segments, right? So let's go back into our processing layer. So what it is trying to do is trying to evaluate each of these fields using so this is now using the AWS Bedrock, right? Based upon that AWS Bedrock, it generates the specification, HL7 specification. This HL7 specification, as I mentioned earlier, this in traditional way of doing things, this would be referred by a developer, using which he or they will create the Mirth channel, which is again in JavaScript embedded in the XML, right? So, and that's what we can see here, right? Using this specification, we are now trying to automate this generation of this JavaScript code. Again, this is done using Bedrock. So it generates the code, and then as we can see, we export this XML in JS code, right? We export this so that this could be deployed in the merge channel, and then we are also validating the logic. Now let me explain here what this step is, because this is interesting. So let's go back to our whiteboard. Let me instead, you know what, let me show you the specification. Let me see if I've done, okay, I don't have it downloaded. What I'll do is I'll go to my S3 bucket here, right, and show you how it looks like. So it's yeah, this is the bucket, and This, let me see if it's in. So this is the raw HL7 messages which get stored here, and in the output folder I have this HL7 specification, right? And then let me download this, and you know what, let me also download the validation report. That way we'll be able to compare it all together. And you know what, guys, let me, before I explain this, right, let me execute this step, right? How so that, because it takes time, right, let me execute this, how this pipeline is put into function. So we have this API request, right? This is exposed using a lambda function, right? And then this is the HL7 messages, which is part of the body here. This is again, yeah, this is this is a Postman application, first of all, right? Using this Postman, we are trying to post onto this API this message, and just, yeah, even header. So this is a JSON format message. Now I'll hit send here, so it should start executing the pipeline. See, it's sending the request. Okay, this is great. So we can see the pipeline started successfully. It may take up to 6 to 8 minutes to complete, right? To retrieve the final validation report, use the below URLs. This is the execution. So at any point of time, you can check the status of the execution, right? And then once the execution finishes, you can download the specification and even the validation report. So you know what, let me just copy paste this in here, and then we'll see this towards the end. And let's see where we are with this execution, just to see if how it's looking like. So I'll just run this here in a browser. So yeah, so it's running. The pipeline is still running. Download URL is not available yet. Progress is 11%. Just just to say. And then the current step is it is analyzing the HL7 fields. Now we can even see that here. If I go exit, and yeah, this is running, right? This is running. This is analyzing the HL7. That's what we saw. Just yeah, right? Now, as this is progressing, right, let me show you, because I had run this, obviously I've run this earlier, how the specification looks like, right? So this is the it's okay. Yep, this is how it looks like. So again, what this is requirements that were provided by the healthcare entity, and the BA, this is sort of needed for now. So BA has understood those requirements, and he or she has formulated this into a technical requirement specification, which looks like this, right? So this is, yeah, so this is the technical specification, and this transform, okay, just let me do this. Maybe this is not formatted correctly, because this should actually come here, right? Yeah, this is a small modification. So yeah, this is the technical specification, right? So data element, the HL7 message, this is the canonical. Canonical is nothing but how this is, we can say, from downstream perspective. It's canonical field from downstream, and this is the source field. So for example, this could be like if upstream is EMR, then source field is from EMR perspective. Let's just write this down here for sake of clarity. And then this canonical is nothing but a lab system, let's say. So this is how the lab system wants the data. And then these transformation rules are again from, let's say, lab perspective. So this is what it says. These are all the rules mentioned here, right? Yeah. And then from column F, G, H, ij, right? So this is the analysis that was carried using Athena, right? The fill rate for each of these, and then the min length and the max length, just to understand the data. And then this sample values, what we saw, right, in the HL7 message originally. This is the sample values, and then this is the expected output that was calculated using these transformation rules. And again, this is done using Bedrock, right? So just for taking a simple example for now, just to show the working of this, right? So here it says that copy only pv1 3.1, which is the first component of pv1 3 field, which is, assigned patient location, right? So this is how the input was in the original messages. And if we see, based on this transformation rule, it only has copied this first component. So these components are separated, these fields are separated by this component separator. So this is actually a component separator, and then this is the first component, and then this is the first value, right? This is the second value, this entire thing, and then this is the third value. So as we can see, it just has just got the first component from each of these values. And similarly, even other rules we can observe, but just in the interest of time, we are moving forward. But again, so to take a step back, right, how let me show you where these, okay, let's see where this is. It's almost at the final stage. Let's quickly see the status here. Okay, it's validating JavaScript logic, right? Yeah. Okay, yep, that's where we are. Okay, yeah. All right, so let's go back to S3 here. I think I mentioned this earlier, but yeah. So these are the rule sets. These could be customized based on the requirements that were shared by the healthcare entities, right? So that is fine, right? And then let me show you the validation report as well quickly. Let's go back here, and then this is it. Now, what this was, these, yes, it's fine. So this is the validation report. Now, this validation report is based on these JavaScript code. So this expected value was calculated or was generated based on these transformation rules, and based on these transformation rules, this JavaScript was generated, right? So this JavaScript would be embedded in the XML format, which is accepted by Mirth Connect, right? And then this validation is based on this JavaScript. Again, applying this input values on this JavaScript, it has generated this actual output. So this actual output is based on the JavaScript code, right? So as we can see, it has also created this validation status is between expected and the actual output. So looks like the transformation rules and then this JavaScript code, they seem to be in line. That's why we have passes here. Yeah, looks like everything is same, which is good, right? Okay, great. This is looking good. All right, so now let's look at our pipeline here. Okay, it has completed. Right, so we'll go back to our API. Right, so okay, so let's quickly check the status as well. Okay, yeah, it's 100%. It's finalized the results, and then here, yeah, it has specification URL download and even the validation report, but I'll just use this what we had copied earlier. So I'll copy this. This would fetch me the, yep, it fetched the specification, right? It fetched the specification. Yeah, this is the same thing, but just downloading it one more time to see the end-to-end execution here. So now this is the validation report. Yep, it downloaded. Right. So let's quickly see this pass and the other. So if there are any failures, right, you will get this in the validation comments. But so far it is all looking all right. Okay. Yep, this is looking good. So this is how, like what we try to do is, just to summarize, okay, quickly summarize what AWS services that were utilized. Right, so I'll go back here. So we've used S3, is needless to say. S3, then we have Athena, then we used Bedrock, right? Athena to carry out the, let's just write this here, analysis of HL7 messages, HL7v2. Bedrock is, it was used to apply, so input values, then transformation rules, and then expected output. So that's when it was used, and then Bedrock was also used to so based on transformation rules, create JavaScript code, right? And then again it was used between these input values, JavaScript code, and then actual output, right? And then we did the comparison. Oh, I mean, even the comparison was done using Bedrock, yeah. So comparison using Bedrock, right? And then finally, right, so these were the specifications, and then in the S3, let's go back here, in the output, yeah, right. So yeah, this is the XML code that I was talking about earlier. Let's see how this looks like. Go to the downloads folder. See, so this is the template, right? This is the template, and this is the JavaScript code that was embedded in the XML, right? So, and then this could be then deployed in the Mirth connect. Alright, so I think that's about it. I hope I did not miss anything, but yeah, again, so just to summarize, why this was needed is to reduce the human effort, or I mean manual effort rather, to reduce the manual effort, which, as we can see, I mean, to carry out the analysis of this healthcare data and creating these JavaScript codes in the XML format. Now, in near future, right, what the plan is to extend this not only for certain HL7 message type. For example, in this case, it was just order message type, but also for other message types. That is one thing, and the second thing is to build a UI, a web-based UI, so that these the request and the responses could be achieved via browser, like in a user friendly way. All right, that's all for now. Thank you. Have a good one.